Alright, today's discussion about what we call a limit in mathematics is super important for setting yourself up to be successful in a calculus course. So, first thing to understand is, what is a limit? A limit is a value that the function or a sequence, we're going to focus on the function part of things, approaches as the input or index approaches some value. So the question you want to ask yourself is, as x goes to a specific number, what is my y value doing? Okay, we don't care about what's going on necessarily at that x value. We care about what's going on near that x value. What is y getting closer and closer to as x gets closer and closer to a specific value? So first thing, we're going to draw in a function. Go ahead and draw this on your notes packet. So we've got part of a parabola, and then we're going to get a jump and have another piece of a parabola. So when we talk about a limit, again, it's what are we getting closer to as an input approaches some value. So if I say the limit as x goes to, let's say, -2. So here's x being close to -2. What is my y value approaching? Well, my y values are closing in on a value of 0. If I say as x gets closer to 0, what are my y values doing? Well, my y values are approaching an answer of -2. But what if I talk about what happens when x gets close to 2? From this side, my y values are going to 0. From this side, my y values are going to 2. These two things don't match up, so we would say that the limit does not exist. Alright, that's a little preview for you. The limit does not exist can be found in a clip of Mean Girls, which we will talk about in class at a later date. So, first thing we need to talk about is our notation for how to write about limits. This is going to be new notation. Make sure you are learning it accurately. So, we write LIM, usually written in script, but you can print it if you would like to. The limit as x approaches c from the left of f of x. Okay. Then we have the limit as x approaches c from the right of f of x. And finally we have just the limit as x approaches c of f of x. So again, formally read, the limit as x approaches, sometimes we say as x goes to c. And then this minus sign would say from the left, plus sign would say from the right. So, the limit as x approaches c from the left of f of x, the limit as x approaches c from the right of f of x, the limit as x approaches c of f of x. Right? So, in order for a limit to exist, it must exist from the left and from the right, and those limits must be equal. So, here we have the limit as x goes to some value a from the left of f of x is equaling the limit as x goes to a from the right of f of x, and we're going to say that those numbers equal L, some number, some limit. Then overall, the limit as x goes to a, just in general, not from the right or from the left, but overall, the limit as x approaches a is also equal to L. Think about it as you're closing in from the left, from the right, and you are converging on the same value of L. So looking at this function, if I asked you to find the limit as x goes to -1 from the left, so here's -1, you want to start following your y values. What is y getting closer to when x is -1? Well, as x gets close to -1, coming in from the left side, my y values are going to 1. The limit as x goes to -1 from the right, so here's x being equal to -1, and I want to follow my y values in from the right. My y values are getting closer to 1, so overall, we call this function f of x. The limit as x goes to negative 1 of f of x is equal to 1. Now, I can do the same thing and looking at when x is 2. Well, the limit as x goes to 2 from the left, so follow my numbers in from the left, getting closer to 4. The limit as x goes to 2 from the right, so here's 2, as my y values come in, getting closer to x being equal to 2, my y values here look to be about 3, so overall the limit does not exist because these two numbers are not meeting up. Alright, lots of practice problems happening here. So, we're going to use this same graph over and over. I'm going to be marking in a lot of different colors, but I want you to try to follow along and see if you can predict the limits as we go. So, this says the limit as x approaches negative 2 from the left. So here's negative 2. Identify that. Coming in from the left, as I get close to x being negative 2, my y value, or my g of x value, is negative 4. The limit as x goes to negative 2 from the right of g of x, so again, here's negative 2, but this time I want to trace my function coming in from the right-hand side, and as x gets closer to negative 2, my y value is getting closer to negative 4. Well, does the limit from the left equal the limit from the right? Yes. So overall, the limit as x goes to negative 2 is equal to negative 4. Next we have the limit as x goes to negative 4 from the left. So trace your function in from the left. My y values are getting closer to 1. The limit as x goes to negative 4 from the right, if you trace your y values, my y value is getting close to negative 2. Please note it doesn't matter that there's an open circle there. We care about what it's getting closer to, not necessarily the value at negative 4. So is 1 equal to negative 2? Hopefully your answer is no. Overall, we would say this limit does not exist. Alright, the limit as x goes to 2, or x approaches 2, from the left. So here's my function coming in from the left. As I get close to 2, my y value is getting close to 1 from the left. Here's x at 2. We want to move in from the right side. My y values are getting close to negative 2. These two things do not equal each other, so the limit as x goes to 2 overall does not exist. The limit as x approaches 6 from the left. So here's my function coming in from the left. Still tracing until I get to 6. From the left, my y values are approaching 1. From the right, my y values are also approaching 1. So the limit overall is going to be equal to 1. As your x values get close to 6, what are your y values getting closer to? They are both getting closer to 1. Alright, next we have the limit as x goes to 0. So here's x being equal to 0. Coming in from the left, from this little negative sign here, from the left, my y values are getting close to negative 1. From the right, my y values are getting close to negative 1. So overall, my limit is equal to negative 1. Again, as your x's close in on 0, what are your y values closing in on? They're closing in on negative 1. Alright, the limit as x goes to 8 from the left, tracing over this crazy function, my y values are approaching 2. From the right, there's not much to trace, but my y values are also approaching 2. So overall, this limit will be 2. Again, as x is closing in on 8, what are your y values closing in on, or pointing to? They're pointing to a value of 2. Alright, the limit as x goes to 4, here's 4, from the left. As I get close to 4, this graph seems to be hitting an asymptote and running forever downwards to negative infinity. As I come in from the right-hand side, my graph is going to approach an asymptote and continue forever to positive infinity. Is negative infinity the same thing as positive infinity? No. So overall, my limit does not exist. Again, as x is going to 4, this is pointing to negative infinity. This is pointing to positive infinity. Those two things are not pointing to the same number, so overall the limit does not exist. Alright, the limit as x goes to negative 8. So, coming in from the left, my y values are going to 4. Coming in from the right, my y values are also 4. So overall, my limit as x approaches negative 8 will be equal to 4. As x is getting closer to negative 8, my y values are pointing to 4. Alright, last limits to look at involve what's happening at infinity and negative infinity. So this deals with what we call end behavior, which we've talked about with polynomials before. So as x goes to negative infinity, where is my function going? It's pointing forever to infinity. The limit as x goes to positive infinity, so as x gets really, really, really big, where is my function pointing to? It's pointing in the negative infinity direction. Last thing, just a reminder, is how to evaluate a function at certain points. So this is going to be useful again and as a lead into calculus. If I wanted to just find g of 0, that just means plug in 0 for g. What do you get? You get negative 1. G of negative 4 says go to negative 4. When you plug in negative 4, what do you get? Well, here we have two options. We have 1 and we have negative 2. But this is the one with the filled in dot. So when you plug in negative 4, you get 1. G of 6, we are at 1. And G of 4, we have a vertical asymptote, which means that G of 4 does not exist. So again, you want to read limits from the left, limits from the right, and if those two values are equal, then the limit overall approaching that value will be equal to that number. We're going to work more with limits from functions in our next unit, but for now we just want to practice reading from the graph.